A bipolar junction transistor is consisted of three semiconductor regions with different dopings. If you remember from the previous part of the course, diodes were consisted of two regions of doped semiconductors, P and N regions. In BJT transistors, we have a three-layer device. So in general, we have two types of BJTs, NPN, which is consisting of two N-type and one P-type layers, or PNP, which is constructed from two P-type and one N-type layers of semiconductor. The operation of these two types is very similar to each other. Let's start with an NPN transistor. For PNP, we can simply reverse the polarities. This terminal is named emitter, indicated by letter E. The middle terminal is named base, which is indicated by letter B, and the other one is called collector, which is indicated by letter C. Keep in mind that the actual structure of the transistor is not symmetrical, so we cannot interchange emitter and collector terminals. The more realistic structure of NPN transistor looks like this picture. And this is a more advanced structure of an NPN transistor. For simplicity, in this course we use this simplified picture. And these are the circuit symbols of NPN and PNP transistors. These arrows in circuit symbols indicate the conventional flow of current. As you see, all currents are in the direction of the arrow. One of the important applications of transistors is amplification. They can produce an output signal that has more power in it compared to the input signal. This extra power comes from the external power source or bias. In future videos, you will learn how to properly bias a transistor for amplification purpose. Inside a transistor, we actually have two PN junctions. The amplification is achieved by transferring input current signal from a region of low resistance, which is the low resistor value of forward biased base emitter junction, to a region of high resistance, which is the high resistance of reverse biased collector base junction. That's why the device is named transistor. And why is it named bipolar? The term bipolar refers to the use of both electron and holes as carriers in the transistor structure. Bipolar is an abbreviation for two polarities. Later you'll see how both electrons and holes participate in the current conduction process. The two junctions, which are base emitter and base collector, can provide different operating conditions, which we are going to consider in this part of the course. So the four possible combinations of base emitter and base collector voltages determine the modes of operation. Before discussing these four possible modes of operation, let's first study the behavior of a BJT transistor and find current-voltage relations. In the NPN transistor you see on the screen, let's forward bias the base emitter junction by applying a positive voltage, let's say 0.7 volt, to base terminal and grounding the emitter terminal. Now I reverse bias the base collector junction by applying a high voltage, let's say 6 volts, to the collector terminal. By looking at the picture, you can easily find that the base emitter diode is forward biased, since the base voltage is greater than emitter voltage. On the other hand, the base collector is reverse biased, since the collector voltage is 6 volts and it is much higher than the base voltage. The depletion region of base collector junction is much greater than the depletion region of base emitter junction, because the base collector is reverse biased. So the electric field E2 created by the base collector depletion region is much higher than the electric field E1, which is created by the base emitter depletion region. Let's see how current flows in an NPN transistor. In emitter, we have lots of free electrons. The doping concentration of emitter is much higher than collector. That's why we indicate this region by N+. The plus indicates highly doped region. And as its name implies, the emitter job is to emit electrons. When we forward bias base emitter, the huge number of electrons in emitter flow to the base region. Some of these electrons will recombine with the holes available in the base or P region, but majority of them will reach the edge of the base collector depletion region. Because of the powerful electric field E2, these electrons will fall to the collector region. So we can say that collector collects these electrons which are emitted from emitter. Let's see what is happening in the base region. The base region is very thin and lightly doped. And by lightly doped, I mean the concentration of holes is low. So most of the electrons which are injected from emitter to the base region get the chance to reach collector without recombining with the available holes in the base region. It is obvious that some of these electrons will recombine with the available holes in the base region. So because of this recombination, the total number of electrons reaching collector will be less than the number of electrons which were originally injected from emitter. Therefore, the transistor's collector current is slightly less than the emitter current. Although the collector current is controlled by applying an appropriate voltage across the base emitter junction, a small amount of current will flow into the base. That's why the base of the transistor will never be empty of holes. The base current will compensate electron-hole recombination in the base area. In the next video, you'll see how current flows in a bipolar junction transistor.